Some researchers believe a singularity can be removed from a black hole have no event horizon, and this would be a wormhole. They modeled observers' objects, like a chair, a scientist, and a spacecraft, as an aggregation of points connected by physical or chemical interactions that hold everything together as the object travels along a geodesic line. A geodesic line is simply the path in space-time that a free-falling object follows. Each particle of the observer follows a geodesic line determined by the gravitational field, says Ruby Ragarsha. Each geodesic feels a slightly different gravitational force, but the interactions among the constituents of the body could nonetheless sustain the body. Research suggests tidal forces would not spaghettify the body. A tidal force is a difference in the strength of gravity between 2 points. The gravitational field of the moon produces a tidal force across the diameter of Earth, which causes the Earth to deform. It also raises tides of several meters in the solid Earth, and larger tides in the liquid oceans. If the tidal force is stronger than a body's cohesiveness, the body will be disrupted. The minimum distance that a satellite comes to a planet before it is shattered this way is called its Roche distance. Human falling into a black hole will also experience tidal forces. In most cases, these will be lethal. The difference in acceleration between the head and feet could be many thousands of Earth gravities. A person would literally be pulled apart. Some physicists have termed this process spaghettification. New work suggests body can stay together. The impact of curvature divergences on physical observers in a black hole space-time, which, nonetheless, is geodesically complete, is investigated. The space-time is an exact solution of certain extensions of general relativity coupled to Maxwell's electrodynamics and, roughly speaking, consists of two Reisner-Nordstrom or Schwarzschild or Minkowski geometries connected by a spherical wormhole near the center. We find that, despite the existence of infinite tidal forces, causal contact is never lost among the elements making up the observer. This suggests that curvature divergences may not be as pathological as traditionally thought. Up of the massive Larsen C ice shelf in Antarctica is getting closer and will eventually produce an iceberg the size of Delaware prowling the Southern Ocean. According to new NASA data, on Friday, NASA released an astonishing new image taken by researchers flying above the ice shelf on November 10th showing the crack is getting longer, deeper and wider. Scientists think it will eventually cause a large section of the shelf to break off. The scientists associated with a NASA field campaign known as Operation Icebridge measured the Larsen C fracture to be about 70 miles long, more than 300 feet wide, and about a third of a mile deep. The crack completely cuts through the ice shelf, but it does not go all the way across it once it does. It will produce an iceberg roughly the size of the state of Delaware, NASA said in a press release. When this iceberg calving event happens, likely within the next decade, it will be the largest calving event in Antarctica since 2000, the third biggest such event ever recorded, and the largest from this particular ice shelf, scientists say. Larsen C lies next to a smaller ice shelf that disintegrated in 2002, after developing a crack similar to the one now growing in Larsen C. Ice shelves breaking off into icebergs don't directly increase sea levels, since their ice is already resting in the ocean, like an ice cube in a glass. However, because they act like doorstops to the land-based ice behind them, when the shelves give way, the glaciers can begin moving into the sea. This adds new water to the ocean, and therefore increases sea levels, in the case of Larsen C. Once the rift extends all the way across the shelf, and breaks off the section of ice, a larger area of ice that is about the size of Scotland will destabilize and be at greater risk for melting. According to other research, in August, a British research team monitoring the Larsen C ice shelf found that the rift had expanded by 14 miles between March and August of 2016. This was the fastest rate of expansion the researchers had observed. The Larsen C ice shelf is the most northerly of the remaining major Antarctic peninsula ice shelves. This part of Antarctica has been warming rapidly in recent years due to a combination of increasing air and sea temperatures. The nearby Larsen B ice shelf made worldwide headlines in 2002 when it broke up after a similar process of rift-induced iceberg calving. The Larsen B event was featured in the opening scenes of the sci-fi climate change-related disaster film, The Day After Tomorrow. Humans need energy, because that's the only thing that powers our smartphones, and without them we'd have to actually talk to our relatives at family gatherings, so it's a pretty big deal that we have an energy plan for the future. The sun is a great source of energy, but it's just too far away, so scientists have been working on a way to create an energy source like the sun, but here on the surface of our planet. Somehow, it's actually working. The idea isn't simple, but I can pretend like it is by describing it in a few short sentences, like this. Instead of nuclear fission, which is essentially the splitting of atoms to produce energy, while also creating nuclear waste, scientists want to use nuclear fusion. Fusion, which is the joining of atoms, produces heaps of energy, but without radioactive byproducts. A device called the Wendelstein 7X, or W7X for short, has made this possible. In a fusion reactor, hydrogen must be superheated into plasma, but that's a real problem, because, as plasma, the substance is so ridiculously hot that it will burn straight through pretty much anything it touches. The W7X accelerator is used to suspend this hot hydrogen in a vacuum using magnetic fields produced with supercooled coils. If the plasma doesn't touch anything, it can't burn it, and the system works. In a paper recently published in Nature Communications, the team behind the W7X, along with several other scientists, confirmed that things are moving along smoothly, and that the magnetic field system works as intended. That's big news, not just for the group, but for humanity as a whole. What's particularly neat about the entire project is that the only fuel that is needed is seawater, which can be used as a source of hydrogen. With no radioactive waste on the back end, a fusion reactor has the potential to provide the world with virtually unlimited clean energy. Maybe 2017 will be okay after all.